Ladies and gentlemen, welcome, welcome, welcome. It is Pags, your lovely host, software engineer, full-time hooligan. So I have a confession to make. I was wrong. I think I was sorely making a lapse in my judgment where I took this tech lead interview position, or took this tech lead interview, forgive me, and I messed it up with the algorithm, right? With the live coding, the algorithm. And my natural knee-jerk response was, well, what a stupid system, what a stupid way to do things, this, that, the other. And although I still believe that to be partially true, I think the much smarter approach is saying, well, let's at least understand the system before we call it entirely stupid. So the video, I forget exactly which Code Chronicles episode it was, but it was more or less me bashing data structure and algorithms, and bringing a really good argument to the table. If we're in a completely different environment, we have different power tools for these problems and these answers that we can use to do these problems, but or to solve these algorithm questions. But ultimately, I do think I was wrong, and I think the smart thing to do is let's get really talented at algorithms, and then absolutely roast them if we still believe that way. And if we don't, more power to us. We're equipping the skill set. We're still learning more about what we need to learn about. So I think it's going to give me a better vantage point on what I want to learn. And beyond that too, my Northern Star is going to be somewhere between, I really do love blockchain development, so I do want to integrate that into the channel at some point. But machine learning has been a fun space for me to play around with, and I've only done really relatively introductory projects, and I've really enjoyed them. So obviously, understanding algorithms on a very, very intimate way is integral to machine learning. So certainly, data structures and algorithms should be something we look into. So we're going to start from scratch. We're going to start from an early thing of algorithms. I'm going to be using Algo Expert for these questions. I'm unsure if Clement doesn't want people kind of giving away the product for free. That's not the goal here. So please, if this is something you enjoy and you want to see a more intimate way, I would highly recommend Algo Expert. They have all these prompts. You can check them out. They have different problems, scratch pads, solutions. They have video explanations. They have a ton of material. You could do it in different algorithms. They have their own kind of in web IDE. You can see different categories, right, of easy, medium, hard, and I believe they have really hard, very hard down here. You could see kind of all these grouped categories by, this instructor, Clement, he's got his questions, right? You got, I think this guy's name is Michael. He's got his questions, and I don't know who this one is, but yeah, so this is where we're going to be pulling from. Let's kind of build a hopefully this becomes a thing. I'm going to try to do an algorithm a day, but we'll probably have algorithm videos maybe once a week. We'll see how consistent I am with it. This has kind of just been day one of it, so hopefully, and so far so good, right? I still want to keep up the Code Chronicles predominantly, but let's dabble into some algos. Let's do it, and let's do it in a new language, Python. Let's bring back those Python skills. So add it to the stack. I'm very competent, I would say, in JavaScript, or relatively competent in TypeScript and JavaScript. I have used Python before. I have done C# and in Java. So learning Python, I think, will not be hard. And mind you, I could definitely sharpen those other languages too. But let's go ahead and do this algorithm. Let's dive in. So we have a target sum algorithm, where let's read the prompt. Write a function that takes in a non-empty array of distinct integers and an integer representing a target sum. If any two numbers in this input array add up to the target sum, the function should return them in an array. If no two numbers add up to the target sum, the function should return an empty array. So we're going to be getting an array into the function, and then we're also going to be getting a target sum. And from what I understand, the problem is we want to add up any two numbers in the array and see if they equal this target sum. So if we did like 8 plus 11, that would be 19. So it wouldn't be the target sum. If we did -4 plus 11, well, that would be 7. So it wouldn't add up to 10. If we did -1 plus 11, well, that would add up to our target sum. So we would pass in those two things, -1 and 11, in an array. So that is the challenge, to pick any two numbers in this array that equal this number. So let's think about it. And in all transparency, I have solved this before, but let's dive in. So, and I believe there's multiple solutions. One is we could set an array, an index, right? Starting here, like a for loop here, and then add the next number to the right of it. If that adds up to 10, we could pass those numbers through. If it doesn't, pop the next pointer over. So we could have a pointer here, and then check each number with this first pointer. And if that doesn't work, then pop this next pointer over. I think that would be an easy solution. Let's see if we can make it happen. So we have an array of numbers. So we could say for, let's see, I in array. Let's see. First num equals array of I. And we could say for j. Wait, this is definitely not how you do Python. But I believe it's different, right? Isn't it range length array, something like that? Python's a little different, right? So we're going to be learning Python syntax, for loops. And we're going to be learning algorithms, for x and banana print x, for x and fruits print x. But how do you print length of an array, right? Length array. Let's see how to loop indexes in Python. Guys, I know, folks. I know someone knows length of colors. Okay, that's what I thought. So range length of colors. Yep, here we go. Print I. Let's start there. Print I. And let's copy this target sum, or this array, and let's pop it into our IDE. So we'll have an array, and we'll have a target sum of 10. So we'll run print I. Print I in array. Is it array -1? Technically. Print I, there are missing parentheses around I. Oh. Folks, we're learning. Okay, so cool. We print the length of this array. It would say first num equals array I believe, right? Let's print first num. Let's see what we got. Should be all the numbers, right? Perfect. Okay, so let's do it again. For j in range, is it length array again? Plus I. Second num, right? Second number equals array j. And let's print the second number. I believe that's how we get the second number, right? Oh, not second none, second num. That's what we want, second num. Here we go. Boom, boom, boom. And let's print these, see what we got, run the code. List index out of range. Plus I, is it +1? Or is it just the length of the array? Okay, that looks like it was working. So we got the first number, we got the second number, I think. Oh, didn't mean to save. And if we do if first num plus second num equals target sum, return first num, second num, right? And then what's the additional part of the array? If any two numbers in the input array add up to the target sum, the function should return them in an array. Let's see, 5 and 5. But we're getting 2 5s. For j in range length of array. That's why I feel like this has got to be a +1 or something. It can't start on the same index as I. Otherwise, of course, it would return 5 5 because it's sending the first I through. Boom, I get 5. That adds up to what we want. Boom. Add up j. If j starts, the next pointer goes 3 5. Boom. That also adds up to 10. So return that. So that's returning 5 and 5, which I don't think. I think it wants two distinct numbers. If any two numbers in the input array. But I guess it's kind of working, right? And we can also return an empty array if it doesn't. So let's maybe remove the 5. We'll put another 1 there. Let's see what we come up with. Print target sum second num array list index out of range. Length array. Okay. Huh. Maybe we're thinking about it wrong. Length array -1. How does the range work in Python again? How does range work in Python? Boom. Range is a built-in function that returns a sequence of numbers starting from 0, increment by 1 by default. Okay, I just want to see kind of the hover thing. Range start and stop. That's what I want. Start and stop. Okay. So we start at length array. So we start at 0, end at length array -1. That seems about right. Okay, and then we start and stop at would we start at I and still stop at this too? Right? Maybe. 11 and -1. Folks, that seems about right. That seems about appropriate. So let's remove the 11. Let's see if we can break the code. Should return an empty array. Nice. What if we change this to 13? See if we have any matches here. Don't think we actually do. Let's try 14. 3 plus 11 should come back. 3 and 11. Nice. Guys, we might have just ripped through a Python algo. Come on, algo Sundays. This could be fun. This could be a thing. This could be a thing. If I do recall, this is something that there's multiple solutions for. So this is kind of a let me think of the time. I think time. This is going to be an O of n squared time, I believe, because there's 2 for loops, or maybe it's space. Is that how it works? Time. I don't think it's that much space though, because there's no hash map, right? But we do have O of n squared time, and I don't know what space it would be. What is big O notation for 2 for loops? Let's see. Thus the complexity is O of n. So the total complexity for the 2 loops is O of n squared. I understand that. But what about space? What is the big O notation for 2 for loops, time and space? Let's see. So I know it's n squared. O of n, yep. Well, no, it's not 2 linear. That's not right. For nested for loops, that's the thing. For nested for loops, for something like this, so we would expect n squared. Yep, it's still n squared. But that doesn't affect O notation. So I don't know time, or excuse me, I don't know space. I think this would be time, right? And for big O notation, I want to show like a chart of what big O notation is, from my understanding. So we want to get to, we don't want to do n factorial. That's like the slowest algorithm. Any number to the nth is also really, really slow algorithms. N squared is not very good. O of n, or n log n, is like pretty solid. O of n is obviously ideal or linear, but very seldomly are we going to have stuff. I think that's O log n, O of 1. I don't think that's a thing very often. I don't know. We'll find out soon. We're going to be diving into algorithms, it sounds like. So let's think of different approaches, I think, of solving this target sum issue. So this is kind of a brute force approach, I feel like, where we're setting one pointer and then sending off the next pointer to the right and just checking. Does that work? Nope. Okay, move this left pointer right here and then check for this number plus 5. Does 5 plus -4 equal our target sum? No. Okay, what about 5 plus 8? No. What about 5 plus 11? No. Okay, what about 5 plus 1? So on and so forth. No. 5 plus -1. What about that? No. 5 plus 6. That doesn't work either. Well, let's move the left pointer over, the I pointer, the -4. What about -4 plus 8? Does that work? No. -4 plus 11? No. -4 plus 1? No. So that's how this algorithm's working. And then we try with 8. And then 11. And then it's like 11 plus 1. Does that work? No. 11 plus -1. Does that work? Yes, it does. Boom. Return. So that's how I think this algorithm's working, where I will start here and then J will start here. And I'll say, does I plus J equal target sum of 14? No? Okay. Then it'll move J over here. Say, okay, what about 3 plus -4? Does that work? No. Okay. Well, then let's move J over one more time. What about that? And then after it gets through the entire loop and ends up down here and says J, what about 3 plus 6? Does that work? No. Okay. Then let's move I. Let's start I right here, and let's try this combination, right? So and then so on and so forth. Then we'll do I plus J here, then I plus J here, then I plus J here. I'm also just buying time where I could think of different ways to do this. Okay, folks, so we could do a hash map, or we could start pointers at the left and right index of the column, which I think would be faster still. So if we started I right here, right, and then started J right here, we can check, do those two work? No. But why don't they work? Oh, but you know what? We'd actually have to sort it first, I think. So if we sort this array first, we'd have the highest and lowest. Yeah, this is what I'm thinking of. We'd have the highest to lowest. If we sort the array first, so all the low numbers would be on the left and all the high numbers would be on the right, then you start with I on the left side with all the low numbers. So if it's like 1, 2, 3, and then ... let's just pretend this is our actual numbers, but they're not. 7, 9, 12, right? So you start with I on the left, and then you say J on the right. We actually need bigger numbers for this to work. 42, boom, because our target sum is 14. We would start with these two numbers, the outside numbers, because that's going to be the biggest range apart. And we'd say, does 1 plus 42 equal our target sum? No. Okay. Is it higher than our target sum or lower than our target sum? Well, it's way over our target sum. So let's move the higher index down one. Okay. Well, what about I plus j now? What about 1 plus 22? Does that work? Well, that's 23. That's bigger than our target sum, but we're closer. We're still higher though. So let's move the right index over. What about I plus j now? 1 plus 12. Does that work? No, it doesn't. But different situation this time. This is because we're less than our target sum. Our target sum is 14 right now. So if we do 1 plus 12, it's actually 13. So we don't need to move the bigger number. We actually need to move the smaller number. Let's try that. What about 2 plus 12? Does that equal 14? It does. Boom. Algorithm solved. So that's potentially another, I think, approach for it. So let's try to do that. So if we say, what do we need to do first? We do need to sort, right? Then we need left index, right? And where does the left index start? At the 0th position. We need the right index. Where does that start? At the length of the array minus 1. Because the length of the array is going to be 1, 2, 3, 4, 5, 6, 7, 8. So it'll be 8 deep, but our positions in our array are 0, 1, 2, 3, 4, 5, 6, and 7. Those are our array of positions. So we do length of array minus 1, so it's minus 1. Okay, let's see. How can we do this? So I think it would still be for looping, right? Well, target sum, what would the target sum be? Target sum would be array of left index plus array of the right index. And let's just print this target sum real quick. Boom. So it should be 9, I think. 14, right? No, now that doesn't make any sense. It shouldn't. 3 plus 6. That should not be working. 14, none. Target sum equals the 0th position here. And the right index. How would that do that? That doesn't seem right, folks. Let's see. Let's print the left index and the right index. Let's see. Oh my God. Maybe it actually is right because it's actually sorting the array. So let's see, sorted array. And just by happenstance, I think it actually is working because the sorted array has how do you reassign variables then? Why does it say none? Why does it do that in Python? How do you print an array in Python? How to print an array in Python, right? Yeah. Do you not just print? Print 2D array. Array is this. Boom. So how do you print it? Print I equals end for I in array. Oh, I see. So I actually need to loop through for I in sort or array. I guess sorted array, right? Print I, right? Think that'll work. And equals boom. Let's see. Okay, maybe I can't do this sorted array stuff. Let's try this. An array.sort. None type object is not iterable. Okay. But happenstance, I do think this is working because our array is going to end up being negative 4 at the very first index, and then all the way at the end it's going to end up being 11. Or whatever it is, you know. where I think just by complete happenstance, it is working. It is working. That is funny. -4, but I guess it still shouldn't be, because if our target sum is actually 11, why would 11 plus 4 equal the target sum? Never mind. That's still not right, folks. 11 plus, how does it get that? Oh, I see. I'm just passing in the target sum. I see. I'm just passing it in from here. So target sum answer. I see. False alarm, folks. Huge false alarm. We need to practice more algos, that's for sure. I see. So that's what it should. Okay, now it makes more sense. Got it. False alarm, folks. False alarm. Okay, so we're sorting the algorithm, and we want to say target sum equals this. Target sum answer equals this. If, let's say, if target sum answer is greater than target sum, was that was the right index moving, right? That was us saying right index minus, right, where we basically said take the right index, pop it back over 1. If we had 1, 2, 3, ... 12, 23, 34, boom, 55, right? So if the right index and the left index, let's say right plus left, 56. So that's way over. That's way too big. So we want the right index to move, boom, right? I think that's what we want. Say else if, now we want the opposite. If target sum is less than, if target sum answer is less than target sum, we want the left index to plus equals 1, right? And then, will that work? I feel like we need the other thing, return none, right? So then elif, return the empty array. So elif, but just else. Ooh, we actually need the case if we don't need this down here. We actually need we need this back here, forgive me, and then we need else if target sum equals left index. We need to return these two, right? So we're supposed to return them in an array. So I think, but hold on, we need to define target sum answer, which is gonna be these guys right here. Let's see. Target sum answer is this, boom, boom. Is that working? Do nothing in our array add up to 14? That's not true though. We have 3 plus 11. Why is it not working? Target sum answer. Let's play it through maybe. Let's print some indexes and see what's going on, right? Let's print target sum answer. 7. Well, that's not helping nothing, right? That's not doing very much for us. It's not doing very freaking much. If target sum answer is this, elif, let's try that. Boom. -4 and 11. That's not what we want, folks. That's not what we want. Two number sum. Let's rename this. I think that could be messing with stuff. Two number sum main.py. Line 9, two number sum. elif target sum answer. Oh, I see. If array dot index is that. Boom. What about that? Still, it's not working. Folks, I might need to crack open the old thing, you know, the old algo expert, right? Hate to do it though. Would hate to do it, you know. Hate to do it. Oh, gosh, it's 10 o'clock at night. I'm so tired. But I need to get better at these algorithms. Oh, I see. So I cracked open the old algo expert. I wonder if I could just use this instead. Like instead of having our code pen and all this stuff, we just look at stuff, talk about jokes. Here looks like some old code here. So array.sort, length of array. And our first solution kind of worked. But in fairness, this is an old thing I've already learned or saw or solved. So maybe we go for a new thing today. Maybe we go for completely something node depths. Let's see. The distance between a node in a binary tree and the tree's root is called the node's depth. Write a function that takes in a binary tree and returns the sum of its node depths. Each binary tree has an integer value, a left child, and a right child node. Children nodes can either be binary tree nodes themselves or none/null. This is that shit I'm talking about where I got no idea. Folks. But okay, so let's try to look at it. Let's try to think about it. So it's going to be the sum of, it looks like all these things. So 8 plus 4 plus 2 plus 1, I think is what it's saying. Or is it saying all of these things? 8 plus 9 plus 4 plus 5 plus 2 plus 1. So here's the tree. 1 sample output is 16. The depth of node with value 2 is 1 deep. The depth of value node with value 3 is 1. The depth of value 4 is 2. Okay, so it's 1, 2 deep. The depth of each node, value 5 is 2, so 1, 2 deep. Summing all these depths yield to 16. Okay, so we have, do we count the 1? Or do we just count the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Got it. Okay. So that is interesting. That is an interesting data structure. So let me think about it. It's like a nested loop, I guess. It's how my brain likes to think of it. So it's like we kind of have an array. And that's like 1. This is where 1 starts, I guess. Right? And this 1. Let's see if we can just keep it all out here. So this is like 1. 1 has 2 in it. it looks like. So it has one, or one's right here. That's our first array. And then we have 2 and then 3. So that's 2 and 3 right here. And then within 2, we also have 4 and 5. So I can break that open. And we have 4 and 5. And then within 3, which would be this one, we also have the 6 and 7, right? And then it looks like on this side of 4 and 5, if this one's the first one, we just have 8 and 9. I don't know if that makes sense, but it looks like we have nested arrays somehow. And I think, and then how would we count that up? So from an array standpoint, I think that makes sense, or like an object standpoint, right? You have like an object and an object. So this is 1, this is 2, this would be 3, this would be 4, I believe. This would be 5, I would believe, and I believe this is 6, this is 7, and this would be 8 and 9, it looks like. So now if we contract those all back together, let's see what it kind of looks like from a array standpoint, or an object. I guess we could do an array or an object with objects within it or something, or an array of objects and all that stuff. But this just looks noisy, golly. So I think what we ultimately need to do. Let me think how to do this. 1, 2, 4, 8, 9, 5, 3, 6, 7. We got this, folks. We got this. We're gonna figure it out. We're gonna figure this out. So I'm gonna do that thing that I originally did. So we have that. Let's bring 1 and 2 down. So let's keep them on their own levels, right? We'll bring 3 on its own level as well. Oh, this was 2. This was the end of 2 right here, I believe. Okay. And this would be 3's start. So let's just kind of look at this for a second. Let's think. So we have a root node. What do we get in our array? We just get root. So do we just get 16 and that's what we're supposed to build out of it? Or do we get the distance between a node binary and a binary tree, and the tree's root is called the node's depth? Write a function that takes in a binary tree and returns the sum of its node's depths. Each binary tree node has an integer value, a left child node, and a right child node. Nodes can either be binary tree nodes themselves. Okay, but what are some of our tests? Can I see the test? So we do have an array. It's kind of cool. Okay, and it looks like the array of nodes has lets us know kind of the structure I'm building here, I guess. So it looks like we have an object, right, called nodes here. But we can get rid of that. We'll just remember that. And this object has an array. We'll say this one is number 1. But it looks like they just have calls to each other. They're not nested to some degree, right? So it's saying, well, this one has 1. This is its ID, right? But the value it has that it branches to is right and left. I see. So the root is 1. Can the root ever change? Can it never be 1? So do we have to check for the first index? Is a question. Value 1, value 2, value 3, value 4, value 5, value. Okay, so the ID and the value are the same, so we can just truncate that to some degree in our minds. Just looking at the example to streamline it. So left and right node. Let's think about it. Const if node, if root is passed guys, this is a tough one, to be honest. This is hurting my brain already. And we're still on the easy ones. We are still on the easy ones, folks. So let's think about it. Let's think about it. So we're not given a stacked array of like what I was saying, where you could see, okay, you have all that. Then I was just going to say, just count the arrays somehow. Looks like we're given data that's pointing to each other, saying, okay, this data can continue to point. So looks like we're given some sort of nodes array, right? It's the binary tree. The root is 1. If the root I'm confused on where we get the nodes, right? Are we passing the nodes in here? Let's just pretend that for now. So if root equals nodes ID, right, we want to do something. We want to check the left and right ID. And maybe we can build that array ourselves, or check the length of, or maybe we don't. Maybe it's all just deceptive, right? We don't actually even need to check the values and the IDs. We just need to check if the left thing has a value in it and the right thing has a value in it. Because let's count these. We have 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, I think, right? 1, 2, so that's 9 right there. So 9, 10, 11, 12, 13, 14, 15, 16, 17. So is it just nodes minus, like nodes length minus 1? Right, so this would be 1. I imagine the output would be 1, right? So we'd have 1, 2, 3. It would be 3 minus 1, just 2. Because we'd have 1, 2. Maybe it would. Maybe it is that simple. So 1, 2, 3, 4. Is the output 4? Is it supposed to be 4? You know what I mean? That would be amazing if that was the algorithm right there. Because then we just have to check the values. So even here, right, you have like all this conundrum. You just ignore all this stuff. You just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So I wish we had the outputs as well with them, because that would certainly make it easy. So let's try to do that, I guess. Let's try to do that. So I don't understand how the test case is coming in, so I'm just going to print root, and let's see. Run code. Raw output, it's a binary tree. Let's steal this, and we're going to go to our code pen. Tree equals this, and we're just going to pass that into our tree as kind of a piece of data, right? And then we will, let's say data equals this. Oh, didn't mean to save it. We'll pass the data here, and we'll actually just give it a root target, I guess. That'll be kind of our root. Say define find root depth will be our algorithm name. Let's see. Whew. And let's go from there, right? If it takes too long, we'll inevitably use our trusty tool. But I think this is a decent approach to it. I want to see if it works. I still don't understand how we're going to get the binary tree here if we're just past the root. If you're just past one, how do you get the rest of all this? It's binary tree self. Oh, I see. It's a little constructor here. This is the class of the input binary tree. I see. So this is what builds the binary tree. So the self and the value. I see. Okay. Okay, so okay. Yeah, let's go back to this then. Algorithm Sundays. What a challenging thing this will be. Algorithm Sundays. I promise though, catch me 30 Sundays from now. Man, I'm gonna be cooking up an ice cream maker machine, you know, some sort of algorithm for ice cream. Let's see though. Okay, so this is the class for this binary tree. Print the root. So if we just submit the code, we're gonna get this binary tree at object, this hash code or this hex code. Can we just not print the binary tree? Raw output. Oh, not submit code, run code. Binary tree. One. How do we even do this, right? How do we even just init the binary tree? You know what I mean? I think we're onto something. If self has a value, just count. So I think we're gonna have a count thing, right? Count equals 0. And back to our thing over here where we'll just kind of build it until we figure out a little more Python, because again, I'm not the most apt at it in this very moment. So count equals 0. Let's just print nodes real quick. See if we can see the data structure. Data equals this. So how do you assign? How do you assign data? You know what I mean? This looks like JavaScript object notation, if you ask me. You know what I mean? So ID 5, right? Boom, 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 boom. Okay, let's just pass in the nodes then. Let's just kind of skip all this jibber jab. Prints. Okay, so ID 5. Just want the nodes, you know. This is not it. This is not it, folks. Okay, I'm gonna ask ChatGPT just a little help on getting us set up for a sec. So let me pop this ChatGPT off screen. Can you get this set up? And let's print all this. I want to print this. Boom. Okay. Oh, got it. So it's kind of doing create binary tree. Oh, it made it a huge thing. It made it all of this. That's not what we want. We just want to access our data and just literally count anything with a string value in it. That's it. So I'm going to ask ChatGPT if this will work. Can you count every node that has a string value in the left or right key? So right, that's all it would be, right? We'd have 1, 2, 3, 4, 5, 6, 7, 8. Oh, and the ID. And the ID key. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and so this should equal 16. Okay, so this is what we have. Boom. To count every boom, boom, boom. Didn't mean to count all the left or right ID provided that you provided. Boom, 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 boom. Let's see. Let's see if it's a good approach, right? Recursively count nodes with left and right substrings or ID ones. We want both. Instance node. Total count. Let's see. This is what it says. Total count, right? Recursively count all the nodes. I'd be so curious if but ChatGPT is not working. It's having the same issue. You cannot do that. Okay. But let's see. So count plus equals boom node.get this. If instance or, how many ors can you do? Can you do another or in Python or another, right? Node get instance of string, right? Or is instance node.get. We also want the IDs. String, right? Is that what this is saying? If the instance is this, count plus one, count plus. I don't know if this is counting too much because it's saying count the values here too. I think count nodes with string values of this, right? If node is none, return 0, count equals 0. So we initialize the count. Let's try it. Let's give it a go. Run code. Line 4. Return 0 if node is none, if root. I just don't know how to work the class situation here. We might have to pop into some solutions, folks, but I really do feel like this would be almost an adequate solution. I'd be curious on what the output is for some of these. This is kind of a bird's eye view thing, but I'd be curious. I think it works, right? If we reduce 1, 2, 3, 4, no, you can't reduce, but we can literally just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 minus 1, 12, right? So, and let's think about what this would look like. If we had that, we're calling that one 12. Let's pop it down here. So we have 1, and it's saying left. Let me put these in the middle, maybe. Or you know what? Let me pop open a lucid chart, right? Let's do that. Let's pop open a lucid app. Boom. Okay, so here is our project. Well, we are now migrating over, introducing this new idea called Algorithm Sunday. So we have left 2, and left also has 3, and 3 also has left 4. Oh, you know what? This may be a different thing. 4 also has left 5. 5 also has left 6, it looks like. 6 just has right 7. 7 has nothing, it looks like. Okay, so what did we say it is from the idea we had, or I had? So that'd be 7 plus 8, 9, 10, 11, 12, 13 minus 1, so 12. So that's 1, 1, 2, so 3, 4, 5, 6, 7, 8, 9, 10, 11, 11, 12, 13, 14, 15, 16. I see. Okay, so that wouldn't work. That would not work. A for effort. Folks, okay, so as you can see, there's a lot of learning I need to do. We are going to definitely dive in though. So I'm going to grind this algorithm out. I'll watch the video explanation. And it looks like I need to brush up on the algos. You know, I think that's probably the weakest point in my skill set right now is probably, it's not third-party integrations, it's not front-end development, even back-end concepts I can come up with, or at least push to get there, struggle to get there, ask Chester on how to do stuff. But data structures and algorithms, I think we can see there's an opportunity for improvement here, and learning a new language, Python too, or at least getting really competent with it, or relatively competent with it would be awesome. So yeah, I think that's the goal, and I think that's what I'm going to try to aim for next. So like I said, every day I'm going to try to do one algorithm a day, and then we'll see how Algorithm Sundays kind of works or not. See if I get a cease and desist for showing Algo Expert. Probably not. But yeah, I think the overall approach was, you know, I was wrong to maybe just downplay and say, you know what, I don't need to learn algorithms. ChatGPT can solve this in 2 seconds. Maybe he can, maybe he can't, you know, and it's probably a good idea for me to at least learn this stuff so that I can build the data structures myself as well. And then finally be a real software engineer. Stop feeling the imposter syndrome, you know? So more to learn, more to come. All right, folks, I'm going to wrap it up here. Cheers. Thank you for watching. And yeah, stay tuned for more Code Chronicles episodes. We will be back on that tomorrow. So I'm very excited to get back into that. I'm loving that build altogether. Thanks again for watching. I will see you on the next one. Cheers.